So even in SHM, we'll have friction. Sound audible है अभी?
Yes, sir, audible है.
So, and this chapter is the problems in this chapter are a little bit challenging. Some certain problems because friction is a special kind of force. We'll discuss why frictional force is a little bit different. Okay, we'll start with a simple case. Is the recording in progress? बता रहा क्या?
Yes, sir.
Yes, sir.
हाँ
दिखा
सर, चल रही रिकॉर्डिंग चल रही.
Okay, fine. So सबसे पहले हम लोगों को first we have to understand what a contact force is. Okay, so there are two types of forces. First one is a field force. Field force ऐसा force है जो दूर से है ना without contact के कोई चीज पे force लगाता. Example, field force का example क्या है? बोलो.
Electrostatic force.
Electrostatic
Gravitational force.
Gravitational force. Okay, now forces are of two types. First is field force. Second is contact force. Now, a field force can exert force on any other body without any actual contact. So examples of field forces are the very common examples. First is electrostatic. Force, you know, when two positive charges are separated by a distance, they repel each other. So when they are exerting repelling forces on each other, there is no need of contact between those two charges, right? If two opposite charges
Yes,
are
sir.
separated by distance, they attract each other. So when they exert attractive force on each other, there is no need of any physical contact. Okay. So second example is gravitational force. There is one more which is also called which is called magnetic force. ठीक है, तो ये सेकेंड ईयर में आते हैं मैग्नेटिक
Yes, sir.
फोर्सेस. ठीक है, तो मैग्नेटिक फोर्सेस, मैग्नेटिक फील्ड कैसा जनरेट होती है, हाउ इलेक्ट्रिक
Sir?
करंट जनरेट्स मैग्नेटिक फील्ड, ये पूरा सेकेंड ईयर में आता है. हाँ बोलो.
Can you repeat the last one where you said the separated by a distance wala?
देखो यहाँ पे फोर्स जब लग रहा दोनों के बीच में, दो पॉजिटिव चार्जेस रिपेल कर रहे हैं एक दूसरे को, ठीक है, तो
हाँ.
दोनों के बीच में कांटेक्ट की जरूरत नहीं है, डिस्टेंस से ही फोर्स
नहीं है.
लगा देता. ठीक है,
हाँ.
same goes for gravitational forces. Now if two masses are separated by distance, they attract each other. There is no actual contact. There need not be actual contact between two particles, right?
Yes, sir. Got
और
it.
two bodies. Same magnetic forces भी है, ये थोड़ा एडवांस है मैग्नेटिक फोर्सेस, वो सेकंड ईयर में पढ़ते. ठीक है, हाउ कैसा देखते हैं
Okay,
मैग्नेटिक
sir.
फोर्सेस का डायरेक्शन, ये सब जो है ना सेकंड ईयर में देखते हैं. ओके, सेकंड एग्जांपल ऑफ कॉन्टैक्ट फोर्सेस. Example of contact forces is, first example which you saw in Newton's laws of motion is normal reaction. Okay, and we'll discuss about this normal reaction in this chapter again.
Yes, sir. Normal
Second is
reaction. Second, frictional force.
frictional force. There may be forces through tension in a string also. Okay, tension और tensile forces बोलते हैं इसको. ठीक है,
Yes, sir.
तो these are examples of contact forces. इसमें जो है ना फिजिकल कांटेक्ट के बिना एक बॉडी दूसरे बॉडी पे फोर्स एक्सर्ट नहीं कर सकती. नॉर्मल रिएक्शन के लिए दो सरफेसेस टच करना, फ्रिक्शन के लिए भी दो सरफेसेस टच करना, और इवन थ्रू ए स्ट्रिंग अगर किसी चीज पे फोर्स लगा रहे तो वो स्ट्रिंग अटैच होके रहना बॉडी पे, बिना अटैच हुए जो है ना फोर्स एक्सर्ट नहीं कर सकता. क्लियर? नाउ
Yes, sir.
in this chapter we will be specially emphasizing on this frictional force. ठीक है, क्योंकि नॉर्मल रिएक्शन ऑलरेडी न्यूटन्स लॉस ऑफ मोशन में बहुत सारा देख लिए. ठीक है, ओके. नाउ आई विल गिव यू फर्स्ट एग्जांपल. देयर इज अ ब्लॉक ऑफ मास m kept on a horizontal surface. ये कौन सा सरफेस है?
Horizontal.
हॉरिजॉन्टल. व्हाट डू यू मीन बाय हॉरिजॉन्टल, पहले ये बोलो. आई टोल्ड इन क्लास
Level surface whose inclination is 0.
हाँ बट किससे देखते, रेफरेंस क्या
सरफेस का
रहता?
स्लोप 0 रहता.
नहीं भाई, एवरीथिंग इज करेक्ट, बट रेफरेंस क्या रहता हॉरिजॉन्टल वर्टिकल?
X axis.
No. X axis, Y axis, we can draw however we want. That is, arbitrary.
Yes, sir.
Sir, n
But
equal to mg.
No. What is the reference for horizontal and vertical directions in real world? When I say horizontal, when I say vertical,
Ground.
no, ground टेढ़ा भी हो सकता ना, रोड ऊपर भी जा सकती, रोड
हाँ.
नीचे भी, ठीक है. रोड need not be horizontal, ground need not be horizontal.
Tangent.
Sorry,
स्लोप भी रह सकता.
Sir,
Tangent
movement of the
plane.
block.
अच्छा
Sir,
जाने दो horizontal
tangent
का.
plane होता.
No. Horizontal थोड़ा
Movement
difficult
of block.
होता. No. Horizontal अगर पूछा तो आपके दिमाग में नहीं आता. मैं easy तरीके से indirect पूछता हूँ, आपको समझ में आता. What is vertical direction?
Opposite to gravity.
Along gravity. Vertical is along gravity. It can be along gravity or against gravity, but it is along gravity. Okay. मतलब in the direction of gravity or
Perpendicular to gravity, I guess.
तो horizontal is perpendicular to gravity. समझ में आया?
Yes, sir.
Clear?
Yes.
अगर कोई वो पूछा
Yes, sir.
आपको horizontal क्या है? Horizontal directions are all the directions which are perpendicular to
Gravity.
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 Friction.
ठीक है. और कितने डायरेक्शन रहते हैं हॉरिजॉन्टल? एक यूनिक रहता है या इनफाइनाइट रहते?
Infinite.
इनफाइनाइट रहते. You know why? Because see, for example, this is vertical. Okay.
हर जगह पे ग्रेविटी के डायरेक्शन बदलते रहता, मतलब I
नहीं.
mean,
I'm talking about at one point only. For example, this is vertical.
Okay. हाँ, infinite.
This is vertical. Vertical is easy. It is along gravity. समझ में आया?
Yes.
Yes, sir.
It is along gravity. बहुत carefully सुनो. Along gravity, along gravitational force. ठीक है? ये vertical है. अब horizontal direction infinite आते इसलिए बोल रहा हूँ क्योंकि if I draw a horizontal plane, बात समझ में आई? If I draw
Yes,
a
sir.
horizontal plane, ये plane में कोई भी direction ले लो आप, it will be horizontal only.
Yes, sir.
Okay. So this is a horizontal plane, right?
हाँ.
So you will have infinite directions ना? समझ में
Yes,
आया?
sir.
How?
मतलब नॉर्थ टू साउथ भी रह सकता हॉरिजॉन्टल डायरेक्शन, ईस्ट टू वेस्ट भी रह सकता हॉरिजॉन्टल, नॉर्थ ईस्ट टू साउथ वेस्ट भी रह सकता, नॉर्थ वेस्ट टू साउथ ईस्ट भी रह सकता, और उनके बीच में बहुत सारे डायरेक्शंस आते. क्लियर?
कुछ भी रह सकता लेकिन perpendicular to
हाँ. So all the directions, every direction in this plane is horizontal. Every direction within this plane, the horizontal plane, is horizontal direction, is a horizontal direction.
Yes, sir.
So in fact, if you think there are infinite number of horizontal directions in real world, देखो, imagine करो, basically आपका जो floor है अगर horizontally construct करे, उसमें कौन से भी direction में line डालो वो horizontal direction ही बताती. ठीक है?
Yes, sir.
Okay. Now this block is kept on horizontal plane. Okay. Now weight is acting downwards and normal reaction will be normal to the plane. That means perpendicular to the plane.
perpendicular.
So normal reaction to any surface is normal. Normal मतलब perpendicular to a plane. देखो, when दो lines की बात करते हैं 90 degrees का perpendicular बोलते हैं, मगर एक plane से अगर कोई line की बात कर रहे हैं तो हम लोग normal बोलते हैं. बात समझ में आई?
Okay, sir.
Okay. So this is normal reaction. Normal reaction will be normal to the surface. So this normal reaction can fully cancel this mg. Do you agree?
Agree.
Yes.
And it will cancel because if you look at the block, it will be at rest. Rest means what? Constant. Displacement is 0. With time, it doesn't change. So velocity is 0. And velocity also doesn't change. So acceleration is
Yes,
also
sir.
0.
Net force is 0.
So net force is 0. For net force to be 0, n must be equal to mg. So normal reaction
Yes,
on
sir.
any body of mass m kept on a horizontal surface will be mg. Clear?
Yes.
Okay. Now
Yes,
let us
sir.
look at a block kept on inclined plane. Suppose ये wedge पे रख दिए जिसका inclination है थीटा. क्या है? थीटा. Inclination क्या है? थीटा. ठीक
Theta.
है? इस पे ये ब्लॉक है. Now its weight will be in vertical direction only. इसका मतलब नीचे रहता, vertically down
Yes,
रहता,
sir.
correct? But normal reaction will be normal to the plane of the wedge. तो ये direction में आता normal reaction, correct?
How, sir?
Yes,
Yes.
sir.
Clear? तो
mg cos theta से
obviously
cancel हो जाता हो.
obviously mg के opposite नहीं है वो. mg के opposite नहीं है.
Opposite
ठीक
नहीं
है?
है.
Yes.
इसका मतलब mg को cancel
sir.
तो नहीं कर सकता है, but mg के एक component को cancel कर सकता.
Component को cancel कर सकता.
mg के एक component को cancel कर सकता. ठीक है?
Yes,
एंड
sir.
आई होप आप लोग
Yes, sir.
कंफर्टेबल है ये थीटा कैसा होता है. अभी तक बहुत
How,
सारा
sir?
करे होगा
Yes,
न्यूटन
sir.
लॉ ऑफ मोशन.
Yes, sir.
व्हाई? बिकॉज़ दिस इज परपेंडिकुलर
हाँ,
टू दिस
sir.
एंड दिस इज परपेंडिकुलर टू दिस. इनके बीच में एंगल थीटा रहा था, उनके परपेंडिकुलर्स के बीच में भी थीटा रहता. तो थीटा के साथ जो कंपोनेंट रहता है हमेशा cos थीटा होता है. जो थीटा के साथ नहीं रहता कंपोनेंट वो हमेशा sin थीटा.
Sin.
एंड वी कैन क्लियरली सी दैट दिस n is capable of totally cancelling this mg cos theta because opposite
Cos
में.
theta. How?
Clear?
Yes, sir.
So n is equal to mg cos theta and mg sin theta is unbalanced. mg sin
Yes,
theta
sir.
is unbalanced. That means there is
Unbalanced.
an unbalance
Force.
or net force down the
Net force.
inclined
Net
plane.
force.
Net force. ठीक है? तो यहाँ पे n is equal to mg cos theta and unbalanced force mg sin theta है.
mg sin
Clear?
theta है.
तो obviously न्यूटन सेकेंड लॉ अगर अप्लाई करे यहाँ पे तो क्या आता?
A is equal to G sin theta.
A
A
equal to
equal
g
to?
sin theta आता.
a equal to g sin theta आता. कैसा? ma equal to mg sin theta, mm cancel हो जाता. a is equal to
G sin theta.
Sir, till 4:45 you're taking class.
yeah.
Okay, sir. Thank you.
I'm recording. If you miss, you can watch the recorded also. I'll just share them.
Okay,
Okay.
sir. Okay.
तो a equal to g sin theta. n भी आ गया, a भी आ गया. Clear?
Yes, sir.
Okay. Now I told you contact forces are mainly divided into two. Contact forces between two surfaces are divided into two major categories. One is normal
types.
reaction, and the second is frictional force.
Frictional.
Yeah.
Frictional force.
Okay. Normal reaction is normal to the surface. Frictional force is always along the surface. You have to remember. Okay.
Yes, sir.
It is present in both smooth and rough surface. Frictional forces may arise on a rough surface only. Rough surface में भी zero रह सकता friction, but smooth surface पे कभी भी non-zero नहीं रहता friction. Clear?
Sir,
Yes,
second
sir.
point, can you explain it again?
See, friction arises only on rough surface. Smooth पे friction नहीं आता. That
नहीं
is the
आता,
meaning
how?
of smooth
Got it,
surface.
sir.
नहीं
Clear?
आता.
But
Yes, sir.
rough surface
sir.
पे भी zero रह सकता friction. For example, ये वाला body दिख रहा यहाँ पे.
Yes, sir. Body rest पे no external
हाँ,
force.
जब
There
rest
is
पे
no
रहता net
external
force कुछ भी नहीं
force,
रहता
so
जब वो
there will
Frictional
be no
force is
friction.
zero. Yes, sir.
Frictional force is zero.
अगर रफ रहो या
Frictional-
प्लेन रहो कुछ भी रहो तो
हाँ.
जीरो चाहता मेरे को.
Frictional force will arise when situation demands. Okay, we'll see that.
How?
Okay, so let us look at this. Now, friction is a self-adjusting force. This is very important thing about friction. What do you mean by frictional force is a self-adjusting force? I will explain. Now, this is a body kept on a rough surface. समझ गए ये कौन सा surface है?
Rough.
Rough
Rough
surface.
Rough surface.
Now, on rough surface, there may be friction present. There may be. Clear? And
Yes,
If we
sir.
apply force then
Yes, sir.
friction.
Clear.
if we apply force. Now there is something called limiting friction. You have to understand limiting friction. Limiting friction is the maximum amount of friction that can arise between these two surfaces. ठीक है? और उसका लिमिट है
sir.
बोल सकते हैं. फ्रिक्शन के वैल्यू का लिमिट है. फॉर एग्जांपल हियर 20 न्यूटन है लिमिटिंग फ्रिक्शन. ओके, क्लियर?
Clear,
Yes.
sir.
F limiting is how
Yes, sir.
much?
Clear.
F limiting is how much?
20.
20 Newton.
20.
That means maximum value of friction that can arise between these two surfaces is 20. Why it is 20 we'll see later. But for this situation, just understand that it is 20.
Assuming.
Now, suppose I apply 5 Newton on this block. So friction will be
5 Newton.
5
Yes, 5
Newton
Newton.
only. Because limiting friction is 20, That means friction can vary between 0 and 20. Friction can vary between
0 and
0
20.
20
0
Newton.
and
Okay,
20.
clear? So
Yes, sir.
when you apply 5 Newton force on the body, still it is at rest. Why? Because the friction is being generated at the bottom between the surfaces,
Yes, sir.
parallel to the surfaces in the opposite direction, and this frictional force is cancelling the applied force. Capital F is
Got it,
applied
sir.
force, and friction is always written in small f. That is the convention. We will follow that. Okay.
Okay, sir.
So the frictional force that generates is 5 Newton. Okay, that's why it is at rest. So when
Yes, sir.
the applied force is less than limiting friction, then the frictional force generated will be equal to the applied force. Are you understanding?
Yes,
Yes.
sir.
For example, if I apply 10 Newton here, frictional force will be 10. If I apply 15 Newton, frictional force will be 15.
15.
15.
If I apply
15.
20,
15.
frictional
20.
force will be 20. But if I
More
apply
than
25,
20, sir? For
that's what I'm saying. If we apply more than 20, like 25,
Equal to limit.
then it will be equal to limiting. It will be 20 only. That means extra 5 Newton net force will come on this. Because that is the limit of the friction. Beyond that, it cannot go. Okay. Understanding?
Yes.
For example, if you
sir.
are trying to move a bench, if you apply small force, it will not move. But if you apply very large force, more than 20 Newton, for example, it is moving because the friction, the applied force has exceeded the limiting friction. That's why, friction is unable to stop. Okay, the bench. So it is
Yes,
accelerated.
sir.
Clear?
Yes.
Yes, sir.
Sir.
And what will be acceleration? Acceleration is F net by M, right?
Yes, yes.
In case of this thing. Acha, if F is less than F limiting, A will be 0. Do you agree?
Yes, the object
Yes,
will
sir.
move.
But in case of F applied is exceeding, in case of F applied exceeds limiting friction, F net will be applied force minus
F
F
net equal to
limiting
M, A is equal to F by M.
F limit
Yes, sir.
by M. Clear? It is F
F limiting.
by mass. This will be the acceleration. Clear?
Yes, sir.
Yes, sir.
So even if F equals F limit, then both the formulas are valid. This is also valid. This is also valid because anyway you'll get 0 if we make these two equal. Clear? So
Yes, sir.
some quick examples let us see. So let us look at some examples. So here limiting is 20 Newton. If F applied is 5 Newton, frictional force is 5 Newton, acceleration is 0. Clear?
Yes, sir.
Yes, sir.
Yes, sir. Clear.
Okay. And if we'll change this. Acceleration is something like this. Okay. Now see, if applied force is 15, friction will be 15, A will be 0. If applied force is 20, frictional force is 20, A is 0. But if applied force is 25, then friction will still be 20. It will not exceed 20. And acceleration will be 25 minus 20 by mass is 10 kg. I have given
Yes,
So
sir. It
Yes,
will
sir.
be 0.5.
0.5 meter per
0.5.
second. square. Clear? Mass did I give here?
Yes, sir.
Yes, sir. You gave.
Where?
No,
Here,
it's M.
10
It's M.
kg.
It's M.
10 kg here.
Okay.
Mass 10 kg. Okay. So if we apply this, you'll get.
Yes, sir.
Okay. Mass is 10 kg. Here also I'll write. Okay. And if applied force is 30, frictional force
Friction is
will be
30
20.
minus 20 by
30
10.
minus 20
10.
by 10, 1 meter per second square. Now, I think you understood what is happening. Clear?
Yes, sir.
Yes.
Got it.
Yes.
Yes, sir.
Now,
Got it.
when this is yellow color, if F is within limiting friction, when it is green, it is it
More
has
than
exceeded.
limiting friction.
Okay, clear?
Yes, sir.
Yes.
Yes,
Okay,
sir.
fine.
Got it.
Now, frictional force is a self-adjusting force and its value ranges from 0 to F limit. 0 to F limit. Clear?
F limit. Yes, sir. Got it.
So friction can adjust from 0 to F limiting depending on the circumstances. Clear?
Okay,
Yeah.
sir.
Okay. Next, let us define what the contact force is. Now, contact force is equal to the net vector sum of all the forces, all the contact forces. Clear?
Yes, sir.
Yes,
Got
sir.
it.
Yes,
So
sir.
because Newton normal reaction is also a contact force, frictional force is also a contact force. So the net contact force is called contact force. So how will you get the net contact force? F contact is equal to normal reaction plus friction, but because these are vectors,
Frictional.
you have to add them vectorially.
Yes, sir.
Okay, and normal
Yes, sir.
reaction is perpendicular to the plane, and friction is along the plane. So
Yes,
angle
sir.
between
Along
them
the
will be
plane.
90 degrees.
90 degree.
So when you add two vectors which are perpendicular to each other, how do you add? Under root of a square plus b square, right?
Yes, sir.
Yes, sir.
Because plus 2ab cos theta will be there,
Sure,
but
because
it will be 0. This will
Yes,
be
sir.
0. Okay.
Yes,
So
sir.
the F contact is equal to n square plus f square. Clear?
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
this thing also you have to keep in mind. Next.
sir, how
Next
did we
way-
get root n square plus x square?
See, these two are perpendicular to each other, na?
Yes, sir.
तो अगर दो वेक्टर्स
So,
परपेंडिकुलर है तो कैसा
cos
ऐड
90
करते
आ
हैं?
जाता वहाँ पे।
अंडर रूट ऑफ a square plus b
First
square
side
करते हैं ना?
is 0.
Ah, yes, I got it.
Okay, clear?
Okay.
Okay, next. Very important thing. Which is called angle of friction. Okay. Now, how is angle of friction defined? Angle of friction is defined as the angle between contact force and normal reaction. Angle of friction is defined as the angle between contact force and normal reaction.
Contact
Normal
force and
force.
normal reaction.
Yes, sir.
As the angle between contact force and normal reaction. And be careful, it is not angle between contact force and frictional force. It is
No.
angle between
Contact force and normal reaction.
Why it is defined like this, you'll understand in the next step, but this is the definition. Okay. Now, so here
Yes,
in the
sir.
diagram, this is the angle of friction. Okay. The angle
sir.
between normal reaction and contact force. Okay, this is the frictional force. Now, according to this diagram, I can shift F here also, right? Because it is a vector, we can slide it.
Yes, sir.
Now, for
Yes,
this
sir.
angle theta, N is the adjacent side, F is the
Opposite side.
Opposite side.
So what is tan theta equal to? F
F by
by
n.
tan theta is equal to F by
F
n.
by n.
Clear?
Okay, sir.
Yes, sir.
Yes, sir.
So in general, what is the contact force?
Contact force is defined as what? Contact force is defined as angle
Force.
between.
Two surfaces.
Contact force is defined as angle between. Tell me.
Two surfaces.
Two surfaces.
No. That is later.
Body.
We'll see that later. That is not the actual definition. The actual definition is angle of friction is the angle between contact force and normal reaction. Okay. So this is normal reaction. This is contact force. This is frictional force. Clear? Now, why this is contact force? Tell me. Why? Because this is the vector sum of these two.
And
So when
square
you
plus
add
square.
these two
Yes,
vectors,
sir.
what will you get? This vector plus this vector. You
Contact
get this
force.
vector.
Resultant.
Clear?
Yes, sir.
Yes,
Now,
sir.
why contact force is written in this way? Because it is the vector sum of normal reaction and
And friction.
frictional. Clear?
Friction.
Clear?
Yes, sir.
Yes, sir. Got it.
Yes,
So
sir.
angle of friction is defined as angle between normal reaction and contact force.
Contact force. Yes.
Clear?
Yes, sir.
Now,
Yes,
if you
sir.
look at this triangle, if I slide this thing here, I'll get a right angle triangle. And what will be tan theta equal to? Opposite side is F,
F by
adjacent
n.
side is
F by
n.
F by n. So tan theta equals to F by n. Can you see that here?
Yes, sir.
Yes, sir.
Yes, sir.
Now you will get some idea why it is called angle of friction. Why? Because as F increases, the angle of friction will also increase, because tan theta is increasing function, right?
Yes, sir.
Yes, sir.
Because tan 0 is 0, tan 30 is 1 by root, tan 45 is 1, tan 60 is. That means as friction is increasing, theta is increasing. If theta increases, tan theta will also increase.
Friction also increases.
Okay, so that's why this is called angle of friction. But in definition, there is no friction anywhere. It is the
Yes, sir.
angle between
Friction and
Contact force
contact.
and normal
Contact
reaction.
force.
contact force and normal
Yes,
reaction.
sir.
Okay, but mathematically we can clearly see as friction increases, angle of
Contact
friction
force
also increases.
increase.
Okay, so tell me,
Yes, sir.
theta is equal to tan inverse of F by N. Correct? From that we'll get this,
Yes, sir.
because when we send tan to right hand side, it will become tan inverse, right? You know what tan inverse is, right?
Yes,
Tan
sir.
inverse of 1 is pi by 4. Tan inverse of root 3 is pi by 3. Tan inverse of 1 by root 3 is pi by 6. Tan inverse of 0 is 0.
0.
Tan inverse of
Yes,
infinity
sir.
is
0.
pi by 2. Okay.
Yes, sir.
90.
Okay, fine. Now, as friction keeps on increasing, it will reach some limiting value. And limiting friction we always represent by F star. Okay.
Yes, sir.
Actually, I represent, in other books they don't. I represent limiting friction by S star, F star, because I don't want to write limit every time. Okay.
Okay, sir.
No.
Yes, sir.
Now when F becomes equal to F star, when F becomes equal to F star, what will happen? See, as I'm increasing the applied force on this block, F will keep on increasing, right?
Yes, sir.
At
Yes,
last,
sir.
it will reach the value F star. It will reach the value F star. After
F
that,
star,
it won't
yes.
increase. After that, it won't increase. Clear?
It will
After
accelerate
that, the
after
It
that.
body
won't
gains
increase.
acceleration.
Okay, it gets acceleration. We are not worried about that now. We are worried about this angle. So what will happen as F is increasing, theta also increases, correct? And
Yes, sir.
theta
Yes,
will
sir.
reach
Directly.
maximum value when F becomes equal to F star. Do you agree?
Agreed.
Yes, sir.
Agree?
Yes,
Yes,
sir.
Okay.
agreed, sir.
So as I'm increasing the friction somehow by applying more and more force, F
Yes,
will
sir.
at last become equal to F star. Okay. And theta will become equal to beta. Theta will become equal to beta.
Beta.
And that
Beta.
beta is called angle of
Angle of
repose.
repose.
That theta is
Angle
called
of
angle of
repose.
and you just think that angle of friction theta lies between 0 and beta, right?
Yes, sir. Yes,
See,
sir.
theta will lie between
0
Zero.
and beta.
beta. See, as if F is 0, theta is 0. As I'm increasing F, theta is increasing, and it will reach its maximum value
At F star.
at F star, and that is what? That
Beta.
is called
Limiting
beta.
friction.
That is called beta. Okay.
Beta.
Okay. Fine.
Yes, sir.
Now this beta is defined as the angle of repose. So what should be the definition of angle of repose? It's the
If theta is increased to F star,
no.
it will become
Okay, fine. But what is the proper definition? It's
The
the
angle between.
no. It's the max-
If the
maximum
theta
possible
Maximum possible angle
possible
between.
value of
Angle.
theta.
angle of friction.
Oh,
Oh, okay.
Angle of friction.
friction.
Clear?
Yes, sir.
So angle of friction lies between. Tell me one more statement.
Angle of friction lies between 0 to beta.
0 to beta.
0 to beta.
Angle of
Yes, sir.
friction. Angle of friction lies between.
0 to beta.
No. Tell me
In what?
statement. In words. Lies between
0 to angle of repose.
0
Angle of repose.
Angle of repose.
and angle of repose.
Yes, sir.
Yes, sir.
Repose. Okay.
Yes,
No.
sir.
I'm writing some more statements here. Just watch carefully. If F equal to 0, theta equals to 0. If F equals to F star, theta
Equal to beta.
Theta equal to beta.
clear?
Yes, sir. Clear.
Yes, sir.
So you have to keep this in mind. And in one more, we look at this angle of friction and angle of repose in another way. When we look at inclined planes, we will see. Okay. Now, here, see, what will be the value of this limiting friction? That is the question now. Okay. Now here some examples are given. Here applied force is 5 Newton. Okay. Limiting friction is how much?
Yes, sir.
So I'll change this and write
20,
F
sir.
star. Okay. Limiting friction is given as 20 F star. So friction will be 5 here. Friction will be 5.
Yes, sir.
Why? Because now our applied force hasn't reached limiting. Okay. So
Yes,
what
sir.
will be the contact force in this case? It will be under root of 5 square plus 10 square. So it will be root 125. Normal reaction is mg, which is 10 Newton, because g is equal to 10 meter per second square. And mass is given as 1 kg. Mass is given as
1 kg.
1
1
kg.
kg.
So normal reaction will be 10 Newton. So if I substitute the values, what will be the value of contact force? It will be root of 125,
Root of 125. Which will be
which is
5
5
root
root.
5.
In the case
Sir,
above,
over here
acceleration.
normal was 10, right?
Normal?
Normal was 10, right? That is why we
Normal
got
was 10. So that's why we put 10
Okay.
here. And friction is 5 because applied force was 5.
Yes.
Okay, sir.
Okay. Fine. Clear?
Yes, sir, clear.
Now
Yes, sir.
here. Applied force is 25. So what will be friction? It will be 20 only.
20.
20 Newton.
Here I'll write F star again, because it will be easy in the future. So tell me, what is this? F contact under root of F square plus N square. So it will be how much? 20 square. Okay. Frictional force is how much?
Yes, sir.
20 square, and normal reaction is 10.
10.
So we got root of 500, which is 10 root 5. Clear? And acceleration is
Yes,
how
sir.
much?
Got it.
This much.
5.
Clear? Okay, fine.
Capital F minus small f by m.
Okay, fine. So let us look at this. This one, not this one. I think this one. This one, right? Okay. Now tell me, in the first case, what will be angle of friction? Angle of friction
Sir, 1 by 2.
Tangent.
is theta equals to tan inverse of
Tan inverse F by
Tan
M.
inverse 1 by 2. sir.
M.
F by
F by n, which is how
N.
much?
1 by 2.
1 by
Theta.
2. Yes, 5 by 10.
2.
Theta equals to tan inverse of 1 by 2. We don't know what 1 by 2 is, right?
Yes,
If it
sir.
was 1
Yeah.
by root 3, we could have written 30 degrees.
30 degrees. Yes, sir.
It
Yes,
was
sir.
root 3, but 1 by 2 we don't know, so we'll just leave it as it is.
We will just level like this.
Okay, in exam also he will give options in this style only. If you don't know the value of 1 by 2. Okay, if he gives all the options in angles, what will you do in exam?
Yes, sir.
If he gives all the values in angles,
Try to switch this into an angle.
no, you should guess. For example, he gives you some.
Yes, sir.
Yeah.
Okay, guess what will be the value of tan inverse of 1 by 2? Okay, tell me, is 1 by 2 greater than 1 by root 3 or less than 1 by root 3?
Greater.
Less than 1 by
Greater,
root
sir.
3.
No.
Greater.
Less than,
Less
sir, less than.
Less than. Less
These
than
two, among these two, which is the greater value?
1 by 2 greater.
Sir, 1 by root 3 is greater.
1 by root.
1 by root 3 is greater because it is 1 by 732, right?
Yes, sir.
Yes, sir.
So this is greater. This value is little bit less.
Less, sir.
So
Less.
in options, whichever option is less than 30 degrees should be your answer. Clear?
Yes.
Yes, sir.
That way also I will give, just to test whether you can guess or not. Clear? One option will be 30, one will
Okay,
be
sir.
45,
Yes.
one will be something like 54, one will be less than 30. I don't know exactly. Maybe 15 degrees, 17 degrees, I don't know. But that will be the answer.
Okay.
Clear?
You can also use
Sir,
it.
can you
Okay, sir,
explain the
got it.
angle on one more time?
See, if you have tan inverse of 1 by root 3, answer is 30 degrees.
Yes, sir.
Yes, sir.
But you can clearly see that 1 by 2 is less than 1 by root 3.
Yes.
So angle also should be less than 30 only.
Yes.
Yes.
And
Yes,
4
sir.
options he has given. Only one option will be less than 30 and that will be the answer. Even if you
Okay.
don't know exactly what tan inverse of 1 by 2
Yeah.
is. Clear?
Yes, sir.
Yes,
Okay.
sir, clear.
What about here? What will be the angle? So here, theta will be equal to tan inverse of
2.
F by N? No, not 2
N.
it. See what is friction here in the second case? Tell me,
Sir, it will be 2.
is it
20.
F is how much?
20.
20
Yes, sir.
by 10. I
20
think.
by 10.
20 by 10.
Last time what was it? 5 by. Okay, fine.
Okay, yes, sir.
So tan inverse of 2. Do you know what tan inverse of 2 is? No, we don't remember that, right? So we'll leave
Yes,
as
sir.
it. We'll leave as it is. What is theta equal to?
Tan inverse 2.
Tan inverse 2.
Tan inverse 2. But can you guess what the value will be of tan inverse 2?
Than 45 degrees.
It will be more than 45 for sure. Because 1 by
Because
root
it's
2
more
is
than
how much? 0.7. Okay. And it will be more than 60
More
degrees.
than
also.
60 also.
Why? Because root 3 is 1.732, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
It will be
It will be
closer
more-
to 60.
Between 60 and 90.
It will be between 60 and 90.
Yes.
It will be between 60 and 90. Clear?
Yes,
So
sir.
one more thing.
Yes, sir.
One more thing. Can you tell me about theta here in second case? What is this theta? Is it special? Is this theta
Yes.
special? What is that?
Angle of repose.
Yeah, this is also equal to angle of repose. Okay. So this theta equals beta. Why? Because it has started sliding, right? So when
Yes.
the object starts
Yes, sir.
sliding, we have to understand that it has acquired, limiting friction already. So that's
So
why,
angle of friction will be equal to the angle of beta.
yeah, here in the second case, this theta is also angle of repose. See, angle of
So
repose is
the
a
angle
Yes,
beta
sir.
we got is angle of repose, right, sir?
yeah, what we got is angle of repose, but angle
Okay.
of repose is also angle of friction. So angle of repose is a
Yes.
special, is a subset of angle of friction. Okay.
Yes, sir.
Yes,
See,
sir.
every angle of repose is angle of friction, but not every angle of friction is angle of repose. Okay, clear now?
Yes.
Every square is a rectangle, but not every rectangle is a square. Clear?
Yes.
Yes, sir.
In that way. Okay. Now, let us talk about coefficient of friction. Now, limiting
Yes, sir.
friction between any two surfaces is proportional to normal reaction. What do you mean by that? If there are two surfaces, the limiting friction between the two surfaces will be proportional to what?
Normal reaction.
Normal
Normal
reaction.
Best example is if you look at brake of a vehicle, harder you press the brake, more the friction will generate. Clear?
Yes. Yes, sir.
Yes, sir.
So you can clearly see that as normal reaction is increasing between the surface, friction is increasing. Clear?
Yes, sir.
One more thing, some of you may know that if a motorcycle is heavy, its wheel will never slip. But if
Yes.
Yes, sir.
motorcycle is very light, like KTM bikes, the chances of tires slipping of tire will be high.
High.
Why?
Yes.
Because if weight is less,
Friction.
normal reaction is less. If normal reaction is less, friction is less. That's why the tire slips a lot. Clear?
Yes. Yes.
So limiting
Yes, sir.
friction is proportional to normal reaction. So I have written this here. Okay, F is proportional to N, and the
Sir, F star
proportional.
should be right.
F
F-
star.
F star is proportional to N. So F star is
Normal
equal to
reaction.
mu into normal reaction. Mu is the proportionality constant. That is called coefficient of friction. Okay.
Coefficient of friction.
Okay. How is
Sir.
coefficient of friction defined? It is the ratio of limiting friction to the normal reaction. Do you agree?
Yes, sir.
Yes, sir.
Okay. So coefficient of friction can be defined as the ratio of
Ratio of frictional.
to the normal reaction.
normal
Limiting frictional force to the normal reaction between any two surfaces. Now the mu will depend on the nature of surfaces, how rough the surfaces are, how smooth the surfaces are. Okay, clear?
Yes, sir.
So actually what happens is if the surfaces are becoming more and more smooth, mu will decrease first, but after they become very smooth, extremely smooth, mu will again increase.
Yes, I got it.
Because if you see the brakes of any vehicle, they are very smooth actually, but friction is high.
Yes,
Okay.
sir.
Repeat, sir.
See, as surfaces are becoming smoother and smoother, first coefficient of friction will decrease and again it will increase.
Slipping.
Got it, sir.
And especially if the material is made of rubber, even if it is smooth, friction will be high. Are you understanding?
Yeah, because it's rubber, it has a high grip.
That's what. That is actually very advanced thing. I don't want to go into that. There will be some shear and stuff, but I don't want to go into that. But roughly speaking, clear?
Yes, sir.
Yes, sir. Got it.
Okay. Now question is, does friction depend on mu? Always.
Not always. Sometimes.
No.
Not always. Whenever the friction has reached limiting value, then it will depend.
Then
But
depends.
if friction is within the
Yes,
limits,
sir.
then
It
it
doesn't
doesn't depend
depend.
on
It does
mu.
not
It depends
depend.
on the applied force. It
Yeah.
depends on the
From the relation only we can.
clear.
Yes, sir.
Yes, sir.
Yes, sir.
So F limiting depends on mu. That is correct. If I say, does F limiting depend on mu? Answer is yes. If I say, does F depends on mu?
No.
True.
No. Does
No.
F
No.
depend on mu? No. Does
No.
F star depend on mu? Yes.
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 Clear? So
Yes, sir.
F depends on mu only if applied force is greater than F limit. Clear?
Yes, sir.
Yes, sir.
Yes, sir. Got it.
So F depends on mu only if applied force is greater than F limit. Okay, F limit I'm always writing as F star. Clear?
Sir, this
Okay,
Yes,
sir.
coefficient
sir.
is
What?
of friction is somewhat not clear, sir.
Which one? Which one?
Coefficient of friction.
See, coefficient of friction is defined as ratio of limiting friction to normal reaction, right?
Yes, sir.
Here, what was the limiting friction? 20. Clear? So what is the
Yes.
coefficient of friction here?
20
20 by 10.
by
2.
10. 2.
2. Here, mu is 2. Clear?
Yes, sir.
No. And what is F star is equal to mu into normal reaction? Do you agree?
Yes, sir.
Here, F star is equal to mu into normal reaction. Agreed?
Yes.
And here, F is also equal to mu into normal reaction. Mu is 2. Okay.
Yes, sir.
Yes, sir.
But here is F equal to mu into normal reaction? No.
No.
Why? Mu into normal reaction is how much? 2 into 10, 20 Newton.
But 5.
But friction is 5. So friction will not always depend on mu. It will depend on applied force also. If applied
When it
force
is
is
greater than.
if applied force is greater than F star,
Limiting friction.
then F will depend on mu. Depend on mu, which is mu into n. Okay.
Yes,
If
sir.
F is less than limiting friction, then
It depends on force.
friction is equal to applied force. It has nothing to do with mu here. Okay.
Yes, sir.
Clear na?
Yes,
Shall I
sir. Clear.
proceed?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Here there are some examples given. Okay. So M is 1 kg, 2 kg, 3 kg, sorry, 5 kg and 10 kg. So different objects are given. Okay. Normal reaction will be how much for 10 kg? Sorry, 1 kg?
10.
10 Newton. For 2 kg, 20. For 5
Yes, sir.
kg, and for 10 kg, 100 Newton. Do you agree?
Yes.
Now let us put what F star is here. What is F star? F star. So what is F star? Tell me. Mu into normal reaction. Mu is 0.5 here. Okay.
Limiting.
Yes, sir.
So tell me what is F star here?
Mu into
5.
n.
5. Here it will be 10. Here it will be 25. Here it will be 50. Agreed?
Yes, sir.
Yes, sir.
Now I am applying different forces on those bodies. And these are horizontal forces. Okay. Which forces?
Yes, sir.
Horizontal.
Horizontal forces.
Horizontal forces I am applying. These are horizontal forces. Okay. So when I am applying horizontal forces, what is happening? In the first case, I am applying only 5 Newton. So this applied force is less than limiting friction in this case. Okay. So this will be 5 Newton only.
Okay, sir.
Clear?
Yes,
Here
sir.
also it will be 5 Newton. Here also it will be 5 Newton. Here also it will be 5 Newton. Clear?
Hi, yes.
Yes, sir.
When I apply 30 Newton, here friction will be
5 Newton only.
5 Newton. Here friction will be 10
10.
Newton.
Here 25. Here 30.
25. But here 30. It will not reach 50 here. Okay.
Yes, sir.
Yes.
Yes, sir.
Okay. If I apply 100 Newton, then frictional force will be 5 Newton only here, because that is the limit.
10,
In that
25, 50.
10, 25, here 50. And
50.
all the red circles are limiting friction.
Limiting
Exceeding,
friction.
So F is
Yes,
equal
sir.
to F star. F equals to F star for red colored circles. Okay.
It is ready to move.
yes, sir.
For other color, I'll write, say this color. No, not this color. That is already done. For blue color, here, this blue color, what can I say? F equals to,
F star.
no, capital F. Okay.
Yes, sir. F equal to capital F.
For blue colored circles, F equal to capital F, but for red colored circles, F is equal to F star. Clear?
Yes, sir.
Yes, sir.
Okay. Now let us go to the next topic. So this is an inclined plane. There is some mass.
Sir, in
Hmm.
the table,
Hmm.
can you show the table on time? I have a doubt.
Hmm.
The values of M, N, and F star, they were given values, or we found them?
See, mu is given,
Okay.
masses are given.
Okay.
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 And applied
Yes, sir.
forces are given.
Okay, sir.
Everything out of circle is given.
Okay.
Everything within the circles we are finding. Okay.
Okay, sir. So we use mu equal to F star by N to find F star.
Yes. We are finding F star. We are finding F also in all cases. 3 cases are there. Case 1, case 2, case 3. 5 Newton applied force, 30 Newton applied force, and 100 Newton applied force. Clear?
Yes. Yes,
Okay.
sir.
Okay, fine. I'll take one more extra page. Here. Okay. Wait for some time. I'll type this on the next page. These are horizontal applied forces.
Yes, sir.
So this is the thing. Okay. So, okay. Now next we will be dealing with what? We will be dealing with inclined plane. What will happen on inclined plane? Let us see. Okay. Now let us see. Now there is
Okay.
one mass kept on one inclined plane. Okay, can you see?
Yes, sir.
Okay. And its inclination is how much? Theta. The inclination of that inclined plane is theta. Okay, clear? Now what is happening here? This block will try to slip down the inclined plane. Okay.
Yes, sir. Got it.
Why? Because the component mg cos theta is
MG
balanced by normal reaction. And mg sin theta is unbalanced. Okay.
Yes,
Now
sir. Unbalanced.
what
F
will
net.
happen? What will happen is this friction will try to stop it from going down the inclined plane.
Sir, rough surface है ये?
Yes,
हाँ,
sir.
Rough surface.
Okay.
So this is mg and mu यहाँ पे दिया ना, mu बोल के दिया तो rough
Yes,
surface.
sir. Diya.
अगर mu equal to 0 बोल के देता तो you have to understand that it is smooth. Okay.
Yes, sir.
Now here we can directly tell what normal reaction is. Tell me.
Mg cos
N is
theta.
equal to mg cos theta.
MJ cos theta.
n equal to mg cos theta, same as for smooth surface. Agreed?
Yes, sir.
Agreed.
Yes.
Yes, sir.
Yes.
N we already found out. Okay, same thing. Now, what will be friction equal to?
mg sin theta.
mg sin theta.
mg sin theta.
It may or may not be equal to mg sin theta.
Yeah,
tell you-
if it exceeds the limiting mg sin theta, then we can tell it.
Okay, if f star depends on n, do you agree?
Yes.
Yes, sir. New and yes.
And f star is equal to,
Sir, mg sin theta minus
mg sin theta.
no, f star is equal to mu into normal reaction.
Yes.
yes, sir.
But what is
Mu
normal
mg cos
reaction?
theta.
N is equal to mg
N
cos
is
theta.
mg cos theta. Yeah.
mg cos theta.
mg cos theta. Clear?
Yes, sir.
Yes,
F
sir.
star is equal to mg cos theta. Okay. But what is f?
Yes, sir.
So here, what is f?
F is mg sin theta.
Sin theta.
mg
If-
sin theta.
if mg sin theta, if mg sin theta is less than f star, then f will be equal to mg sin theta. Are you
MG sin-
understanding?
Yes, sir.
Yes, sir.
Yes, sir. Got it.
Why?
Yes.
Why? Because now the force that is trying to bring it down the inclined plane has not exceeded f star. That's why the frictional force will adjust. Because I told you already in the beginning, friction is a
Yes, sir.
self-adjusting force.
Self-adjusting.
Yes, sir.
Then f must be equal to mg sin theta. Do you agree?
Agreed, sir.
Yes, sir.
Yes, sir.
And the net force is along the surface becomes zero, and the block remains at rest. Are you understanding?
Yes, sir.
Yes, sir.
Okay, fine. Okay. Now, if mg sin theta is less than f star,
Sir, greater than.
is greater than f star, what will happen?
Then friction will be equal
So
to
the
F
block will
limit.
slide
F
down.
limit. Yeah.
Friction will be equal to f limit.
F
Friction
star.
will be equal to
F star.
f star and mu
Mu n, which is equal to mu mg cos theta.
mu mg cos theta. Clear?
Yes,
Yes.
sir.
Unbalanced
sir.
force will be mg sin theta.
mg sin theta minus mu mg cos
Mu
theta.
mg cos theta. Yeah.
Unbalanced force will be along the surface
F
down the
minus
inclined
F.
plane. Net unbalanced force is
Along the surface.
down the inclined plane, I can say.
Yes, sir.
Yes, sir.
Down the inclined plane. And F net is equal to mg sin theta minus mu mg cos theta.
Sin
Agree?
theta minus nu mg cos theta.
Yes.
Yes, sir.
I'll write it again. mg sin theta
Sin theta minus mu mg cos theta.
mu mg cos theta. Okay. So according to second law, what can I write? F net
Yes,
is
sir.
equal to
Ma
ma.
is equal to
M
mg.
A equal to mg sin theta minus mu mg cos theta.
M will cancel.
Yes, M will be cancelled, G common.
Yes. A is
Yes, sir.
Okay, I'll
Yes,
just
sir.
copy this. So this is equal to this. Now, if I cancel that, A will be equal to G will come common, and in the bracket, sin theta minus mu cos theta will remain. Clear?
Yes,
Clear,
sir.
sir.
Yes, sir.
Yes, sir. Clear.
Okay, fine. Now,
सर वो वाला फिर से बताना ऊपर.
कौन सा?
If mg sin theta greater than or equal to f star वाला.
यही है ना?
हाँ.
क्या डाउट है उसमें?
मतलब एक बार एक्सप्लेन करो पूर्ण सा.
If mg
Then
sin
उसके
theta
बाद वाला.
इससे पहले का ये वाला
नहीं सर
नहीं
वही.
उतना पहले नहीं आगे का बोल रहे हैं.
ये वाला
हाँ.
if mg sin theta is greater than
हाँ
f
सर ये
star.
वाला.
Now देखो mg sin theta is the force that is trying to pull the block down. Now that
Yes,
is
sir.
greater than f limiting. That means it has given up. It will start sliding. See, the block and the surface will stay together until the applied force is less than limit, within the limits. As soon as this
Yes, sir.
increases, as soon as this value increases, the friction will give up. It will, reach its maximum value and
Yeah.
it will stop. So there will be some net force down the inclined plane. So it will accelerate. And
Yes,
what will
sir.
be the net force down the inclined plane? It is mg sin theta minus f limiting, f star. F
Yes,
star
sir,
will
got
be
it.
equal to mu mg cos theta because mu n is equal to mu mg cos theta. Clear?
cos theta.
So
Yes,
that-
sir. I
Yeah.
got it now. After
that we have
referring with
written
that.
here, and we have written f equal to ma. We cancelled m, we took g common, and we got this expression. Clear?
Yes, sir.
Yes, sir.
Yes, sir. Got it.
Okay, fine. Here in the first case, which case? When f star was equal to mg sin theta, here in the first case. Okay, anyway,
F was greater than.
till here you understood? Till here?
Yes,
Here,
understood.
Yes.
here a is 0, here a is g sin theta minus mu cos theta. Now if theta is, okay, this I think we'll do in the next page. I'll tell you one more.
Yes, sir. You went on the next page.
I'll tell you one more thing. Where is this angle? Okay, this
It starts from here.
this will make in the next page. Okay. Okay, I'll show you one more thing. I'll show you one more thing. In the first case, can you see that frictional force is equal to how much? In the first case.
mg sin theta.
mg sin theta.
So here, let me just separate these two. Okay, I'm separating these two. So this is the second case after this line.
Yes, sir.
So above that line, it is the first case. Okay. Now, in the
Yes, sir.
first case, can you see that f is equal to mg sin theta?
Yes.
Yes, sir.
Yes, sir, we
Because it
can
is
see.
under the limits.
Okay, one more thing. What will happen to this block in the first case? Will it remain at
It
rest?
will not move. It will
It
not
will
move.
not move.
Remain
It
at
will
rest.
It will remain at rest, right? Okay.
Yes, sir.
Now watch carefully. If I
Yes,
take
sir.
this diagram, if I take this diagram and draw here, I think here space is not enough. If I take this diagram and draw here, watch one thing. One thing, very interesting thing is there. So, can you tell me what is the contact force, direction of contact force here? It will be something like this. Do you agree? It will
Yes,
be
sir.
between.
Yes, sir.
It will be between frictional
F
force
and
And normal.
So this will be F contact. Clear?
Yes,
Now,
sir.
because these two are perpendicular, what is F contact? Tell me.
Root n square plus
n
Under
square
root
plus
n
f
square
N
plus
square
f
plus h
square.
square.
Very good. Under root n square plus.
f
So under
square.
root
square.
In the
mg cos theta
in the
square
first case, it
plus
will
mg
be,
sin theta square.
yeah.
Which is equal to under root of
M
normal
square g
reaction
square
flow,
cos square theta.
mg
mg cos theta whole square.
Cos theta whole square.
Plus
plus
mg
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 sin
sin
theta
theta
whole
whole
square. In the
mg
first
sin
case.
theta
Sin
whole
theta whole
square.
square.
So here mg will be common and it will come out, right?
Yes.
Yes, sir.
Yes. Cos square theta
Answer
plus
is
sin square
mg
theta.
only.
cos square theta
mg.
plus sin square.
F contact is equal to
One.
mg only.
Yes, sir.
Yes, sir.
mg only, sir. Yes, sir.
Mg only. Why? Because cos square theta
Sin
Yes.
square theta plus cos
theta
square theta is 1.
is 1. Clear?
Yes,
Now,
sir.
now think about it. There are two forces acting on this. Actually, one is weight and one is contact force.
Yes, sir.
Okay, one is weight and one is contact force. And clearly, contact force must be cancelling the weight. Only then it can stay at rest, right?
Yes, sir.
Yes,
Repeat,
sir.
sir, the point.
See, forget about frictional force and normal reaction because we combined these two and we condensed into contact force, right?
Yes, contact force. Yes.
So forget about friction and Newton because we included both in this force. So if we consider this force and weight, only two forces are acting on this body, right?
Yes.
Yes, sir.
And because it is at rest, net force must be 0. That means this must be cancelling this, na?
Yes.
Yes, they must be equal.
Yes,
They
sir.
must be equal. That's why F contact is equal to mg.
Got it, sir.
Clear?
Yes, sir.
Yes, sir.
Yeah.
We got it from other way, but logically speaking, also F contact must be equal to mg only. Otherwise, it will not stay at rest.
Yes, sir. Got it.
Clear?
Yes, sir.
Yes.
Okay. One more thing here. One more thing. It is which one? This one only, na? This slide. this slide. One more thing.
Yes,
What is angle of friction here?
So the angle between normal and
Weight
force,
between
contact
normal
force.
and force.
What is angle of friction? Tell me.
Tan inverse
Angle
by
between contact force and
Contact
normal.
force and normal.
Okay. So what is it?
tan inverse F by N.
Okay. Theta equals to
Tan inverse F by N.
tan inverse F by N.
N.
Clear? So tell me
Yes,
what.
sir.
F is equals to
F
mg
cos
sin theta by mg cos theta. Means
tan theta.
Theta is equal to mg.
Theta.
Theta equal to tan inverse of
Tan theta.
Tan theta.
we made a
Sir, can you tell this one again? I didn't understand.
so okay. I know some problem is there here actually. This angle also we took theta.
Yes, sir.
Did not take theta. Shall we take angle of friction as something else?
Alpha, sir.
Alpha.
Alpha.
Angle of friction alpha. Okay.
we'll think that angle no sir in the inclination
Alpha,
angle.
we will get alpha equal to theta.
Alpha equal
Then.
to theta.
No problem. We can change that also.
Yeah.
We can change this also. No, not a big deal. I'm changing this because otherwise I have to take out that from the diagram.
Otherwise, theta will be equal to theta.
Okay, I'll try. Wait. All diagrams I have to change. Leave it. This is better.
Okay sir.
Okay. So what
So
is
you told
alpha
you
equal?
repeating.
Theta.
Into tan
Alpha
theta,
equal to
right?
tan inverse tan theta.
So tan inverse of tan theta is theta only.
Cancelled.
Yes sir.
Alpha equal to theta.
Alpha equal to theta. So as long as the block doesn't slip, angle of friction will be equal to angle of inclination. Do you agree?
Yes, sir.
Yes, sir.
Yes.
Yes sir.
So
Sir, one time.
as long as the block does not start slipping down the inclined plane.
No, I meant this angle of friction.
See, angle of friction we got as alpha is equal to theta in the first case.
Yes.
So as long as the body is not slipping, that is the first case, right? Body is not slipping. Clear?
Angle of incline is
Yes.
equal to angle of friction.
As long as the block
Does not slip.
remains at rest,
Angle of friction is equals to angle of inclination.
angle of
Yes,
friction
sir.
equals angle of inclination.
Inclination. Yes.
Yes, I got it.
Clear?
Yes sir.
Now, as you are increasing that angle of inclination, at some angle it will start slipping, right? When the angle becomes
Yes, sir.
big.
Yes.
Yes sir.
There, what happens is it has reached. This is, we'll cut it. It has reached what? So in other words, what can you say? As long as friction is less than limiting friction, angle of friction is equals angle of inclination. Agreed?
Angle
Sen?
of
Yes sir.
Yes, sir.
Yes, sir.
Agreed.
You can write in symbols.
Okay. Anyway, just statement I'm writing. Okay.
Okay.
Now, tell me what happens if our angle is increasing and it is starting to slip. Here, if mg sin theta is greater than f star, then f is equal to f star, right?
Yes,
Then F star
sir.
value will change.
Value will change, right? And here we got
Yes, sir.
acceleration
Nu
as
mg cos theta.
g sin theta minus mu
F
cos
by N
theta.
also will change.
Okay. So here, what is tan theta equal to? Okay, I'm just erasing this. Tell me.
Okay, sir. Now, sir, alpha will be equal to tan inverse neo, I guess.
Yes. So here, Let us find angle of friction. Tell me. What is angle of friction? Theta
Angle
equals
of
to
friction.
Tan
Theta
inverse
equal
F by M.
Inverse nu.
tan inverse of F by N.
F by N.
F by N. F by N. But here, what is F equal to?
Nu mg cos theta. Sin theta.
Mu mg cos theta. No.
Sin theta.
Friction
Sir,
is
yeah, mu mg.
mu mg cos theta. Mu into normal reaction.
Yes,
na?
sir.
By
Yes,
normal
sir.
reaction
By
is
n is
H
mg sin theta. mg cancel mu cos theta by.
otherwise we'll just write mu into N by N.
Yes, sir. By
Because-
N.
So
Tan
theta equals
inverse
to
mu.
Yes, sir.
theta
Tan
equals
inverse
to
of
Theta
tan
equal
mu.
to tan inverse nu.
But what is tan inverse mu? Tell me.
Tan
Yes, sir.
inverse nu is angle of friction. Angle of repose also.
It is angle of repose also.
Yes, sir.
Did you see? Did we already derive this?
No.
We didn't derive this.
Yes,
Here?
sir. Derived.
Yes, sir.
We have it.
Here.
We derive.
One second. Here is angle of friction. Yeah, here. Tan inverse of mu.
Yeah.
Remember? Clear?
Yes, sir.
Yes, sir.
What is the alternate definition of angle of repose? Tell me here, according to this.
Then it will be beta is equal to tan inverse of mu.
No.
When
According
angle
to
of friction is
When
greater-
angle of friction is limiting. Just
here, where are you? Here. Here.
when angle of friction is more than the inclined plane. Inclined angle.
Okay. But we can define one more way, right? If we define,
What?
we can define angle of
Okay.
friction in one more way.
Angle of between F contact and friction.
No. See, where is that? Here. See, suppose you have an inclined plane, there is a block on the inclined plane and you are slowly increasing the inclination from 0 to some angle. Okay. Now, angle at which the block starts slipping is the angle of repose. Do you agree? Clear?
Sir, can you repeat the
Yes,
last
sir.
one?
Clear.
On an inclined plane, on some horizontal surface, you put some block. Now you are increasing the inclination slowly. Okay.
Yes, sir.
Okay.
So after, see, for small angles, it will not slip. It will remain at rest because friction will take care. But as soon as the angle increases significantly, when the
Yes, sir.
mg sin theta value will cross mu mg cos theta's value, it will start slipping. Now the angle at which it starts slipping will be the angle of repose. Na?
Yes, sir.
Yes, sir.
Clear?
Because it exceeded the F limiting.
See, if theta is greater than tan inverse of mu, the block will accelerate down the inclined plane. If theta is less than tan inverse of mu, the block will remain at rest. Do you agree?
Yes, sir.
Agreed, sir.
Okay. Here. If theta is greater than tan inverse of mu, the block
Will accelerate down.
accelerates down the inclined plane. Clear? Okay.
Yes, sir. Clear.
If
Yes,
theta
sir.
is less than tan inverse of mu, it will remain at rest. Do you agree?
Yes, sir.
Yes.
Yes, sir.
Okay. So if you slowly increase angle from 0, what will happen? The situation. Tell me. It will remain at rest first.
Yeah, remain at rest. Yes.
As soon as the angle reaches tan inverse of mu value, it will start slipping. Clear?
Slipping. Yes.
Yes, sir.
So what can we say?
As soon as the angle of repose is attained, it will start slipping.
Okay, fine. Anyway, here, if theta is, acha, did we take alpha as angle of repose?
No, sir, we have taken beta as
Angle of
angle of
friction.
repose and angle of
Beta
friction.
is angle of repose.
Beta is
sir.
equal to tan inverse of mu.
Okay, fine. Beta we have taken as angle of repose, right?
Yes, sir.
Yes.
Fine, not a problem then. So if alpha is equal to tan inverse of mu, then that
Okay.
alpha
We
will
took
become
alpha only.
angle of repose. Clear?
Yes, sir.
Sir,
Yes,
here
sir.
change to beta, no? Alpha.
What?
We will change alpha to
Beta is
beta.
called angle of repose, no, sir?
Yes. From that
Ah,
we are taking beta as angle of repose.
No, here we will write alpha is equal to beta. Right? Clear?
Yes.
Yes, sir.
Alpha. So I'll just change the words, you'll understand. Alpha equals angle of repose.
Okay, I got it, sir, now.
Okay. See, these are not universal symbols. Don't worry.
We are just
Equal
assuming.
angle of repose. We are just choosing this alpha beta. Okay. Different books will have different these things, parameters. Okay.
Yes, sir.
Now mu can vary between 0 and infinity. Do you agree?
Yes, sir.
Yes.
Why? Because see, what do you mean by infinity? What should be the angle for mu to be
90
infinity? Tell me.
degrees.
90
90
degrees.
degrees.
So if see mu is equal to tan theta, right? So if something
Yes, sir.
can stand on a vertical wall, can we say that friction between that object and the wall is coefficient of friction between that and wall is infinity?
yes, sir.
Yes, sir.
Okay.
Yes.
For example, if a lizard is staying at rest on a vertical wall, so can you say that coefficient of friction between the limbs of the lizard and the wall is infinity? Just mathematically.
Yes, sir.
No.
Actually, that is an advanced thing because there will be some van der Waals forces between the legs of the geckos and wall, but we don't want to go into that molecular level, but just from a broad overlook from point
Yes,
of
sir. It will be
physics,
equal to infinity.
mu will be infinity, correct? So mu
Yes,
can
sir.
vary from 0 and infinity. For example, if mu is 0, angle of repose will be, so here we'll change as beta. Okay.
Yes, sir.
Now here, because we have chosen it as beta, right? Angle of repose.
Yes, sir.
So if mu is 0, then beta is 0. That means it will remain at rest only on horizontal surface. Even by 1 degree, if you rise, it will slip. Okay. If mu is 1 by root 3, you can increase the angle up to 30 degrees. It will remain at rest. Above 30 degrees, it will slip. Do you agree?
Yes, sir.
And if the value of mu is 1, till what angle will it remain at rest?
45.
45.
And if angle is if mu value is root 3, then up to 60 degrees it will not slip. After 60 it
Tan
will slip.
inverse of mu because
Okay. If mu is infinity, no matter what you do, the object will
Angle
not
of repose will be
slip.
90.
Angle of repose will be 90. Clear?
Yes,
sir,
sir.
in place
Yes,
of
sir.
beta we can write alpha also, no? Because we just now proved alpha is equal to beta.
No problem. Yeah. We are just writing. Okay. Some arbitrary symbols. Don't worry about that.
Sir,
But these
can we
are all
continue this tomorrow, sir?
okay. I'll just write here and I'll end the lecture. We'll continue in the next class. So here beta is what?
Angle of repose.
Angle of repose. And don't worry, alpha beta, if you are using interchangeably, no problem. Okay, clear? We'll continue tomorrow.
Yes, sir. Okay, sir.
Okay.
Okay, sir, thank you.
I'll share this. You just go through properly.
Okay, sir.
Okay,
And
sir.
you
Thank
try
you,
to
sir.
you
Thank
try
you,
to
sir.
Thank you, sir.
okay. You try to understand the notes in the later pages also. In the next class, it
Okay.
will be easy.
Okay,
Okay,
sir.
sir.
Okay, sir.
Okay, sir.
Grid lines.
Grid lines shall I remove?
Yes, sir.
Yes, sir.
In morning PDF also, sir. SHM की.
और एक चीज एक काम करो, कोई तो भी इन्वर्ट करके भी शेयर करो ग्रुप में, इजी प्रिंट कर